Hello, everyone. Welcome back. Today we are going to be talking about transformations of trigonometric functions. All right, so first things first, let's draw the primary trig functions and just what they look like ordinarily. Okay, so with sine, we're going to start with 0, and then we're going to go 1, 2, 3, 4, like that. Excellent. And then as we know, we're going to go up to 1 and down to -1. So we're going to start here at 0, 0, and then we're going to go here at pi over 2, pi, and then 3 pi over 2, and then 2 pi. And I'm sure you've already seen this. You may have only ever seen it with degrees before, not with radians, but now we're familiar with radians, and we know how to do radian measures, so we're good. But this shape of this graph should be very familiar to you, right? It's just the same as sine always was. Okay, and then same with cosine. Same with cosine. We're going to do 1 here and -1 here. And then we'll do 4 for each pi over 2, pi, 3 pi over 2, and 2 pi. And there we go. There we have it. Okay, so then we have 1 pi over 2, down to -1, back up to 0, and 1. There we go. Awesome. Excellent. We did it. Okay, and what about tangent? So this might be the only one that you might not have seen before necessarily, because I don't think this is generally taught in the grade 11 curriculum. Maybe sometimes it is, but generally no. Okay, so let's talk about what does this look like. So first of all, this is going to have some asymptotes here. Let's say this is pi over 2, and this is negative pi over 2. Next one. There we go. And then we're going to have this looking like that. And so on. So that's what our tan graph looks like. It looks quite different from our sine and cosine graphs. But I mean, sine and cosine are a lot more related or at least in a lot more ways, I would say, that are noticeable than, tangent is with either one of them. Okay, so there we go. There we have it. Let's talk about a few key points quickly as well. What are our key points for each of these? Well, our key points for the sine one are 0, 0. And then we have 2 pi over 2, 1. Then we have pi back down to 0. Then we have 3 pi over 2 down to -1. And last but not least, we have 2 pi and 0. And then over here, we have cosine. What are the key points for cosine? Well, 0, 1, we start at 1. And then we have, for pi over 2, we have 0. And then for pi, we have -1. For 3 pi over 2, we're back up to 0. And then for 2 pi, we have not 0, we have a 1. As for the tangent graph, what are our key points? This might be new, so definitely pay attention for this one. 0, 0 is a key point, as is negative pi over 4, -1, and also pi over 4, and 1. So actually this should be more like that, because that is a key point. So I should make sure it looks more like it is. But there we go. So as we know, a trigonometric function in the form of g of x equals to a sine k times x minus d plus c can be graphed by applying the appropriate transformations to the parent function f of x is equal to sine x. So trigonometric functions are periodic, so the period of the function can be found by using this formula. The period is 2 pi over the k value. So example 1 asks us to, in words, just describe the transformations that must be applied to the graph cosine of x in order for us to get g of x. So there's actually an entire video in, I think it was lecture 1, or not lecture 1, sorry, in unit 1, that was all about transformations of functions in general. So if you're not familiar with transformations of functions in general, definitely go review those, because this is a whole topic in and of itself. But that said, so all we have to do now, if we know that topic, is to apply it to this situation. So what does the 3 mean? What does 3 with a mean? Well, that means that we have a vertical stretch by 3. Vertical stretch by 3. Then we have a minus 1 as our k value. So what does that mean? Well, if we have a negative sign there, it means we reflect it across the y-axis. So let's say reflect in the y-axis is all that means. The negative sign is still a negative 1, right? And so we don't actually have to do anything with the period length. It just stays as is. And then what else do we do? The plus 2 and minus 4 tell us that we must go left 2 and down 4. So shift left 2 and down 4. Now, a lot of people forget, they see the plus 2 and they think, oh, we're going right 2. But keep in mind, the original way, we have a minus sign here. And so that means it's actually the opposite of what we would think. If we have positive here, that means that the actual d value is negative, which is why we go left. And if we have a negative there, or if we have a positive for d, then it's going to read as x minus and then a positive number. So it's going to look negative, but it's still going to be going right. So D sometimes is the opposite of what we would imagine, because we forget that that negative is already there. There's a negative there. So if we add a second negative, that makes a positive, right? But still means we're going left. Okay. What about this one here? Well, first of all, I see a negative sign, which means it's reflected in the x-axis. So let's write that down. Reflect in the x-axis. So that's our first part done. What's the second thing we're going to do? Well, I see 1/2 there, which means we're going to do a, oh no, actually, before we do that, there's also 1/4. It's going to be vertical compression by 1/4. Vertical compression by 1/4. Then we have 1/2 as our k value, which means we're going to do a horizontal stretch by factor of 2, or in other words, the period length is going to change, right? Our k value is 1/2, and so our period length is going to go from 2 pi to 4 pi, right? Which means we're going to do a horizontal stretch by 2. And then last but not least, we're going to shift right 5 and up 6. So that's our final step there. Very good. Very, very good. All right, so let's move to example 2. Example 2 says, given the parent function f of x is equal to tan x, state the equation of the function that results from each of the following transformations. Okay, so therefore, let's see. The first one says vertically stretch by factor 3. So that means our amplitude is 3, or that we start with 3. Then it says reflection across the y-axis, which means we're going to have a negative number here. We're going to put a negative sign to show it's reflecting across that axis. It's also horizontally compressed by a factor of 1/3, which means we would have a 3 here with that. Then it is shifted 5 left. So we'd have x plus 5 in here to show that shift. Nothing at the very end, though, because it doesn't indicate that it's shifted up or down, just left versus right. Very good. Okay, let's move on to example B. How would this be for reflected across the x-axis? Well, we would have a negative sign for reflected across the x-axis. Then it says horizontally stretched by 5, so we write tan, and then a fifth. And then it's shifted right by 6, like that. And then we would add 12, right? Because we're going to go up 12. Very good. Very, very good. And yeah, that is that. Okay. So now we're going to actually do some graphing. Here it says, given the parent function f of x equals cosine x, graph this function and state the equation of the axis and state the period of the function. So actually, before I sketch this graph, I'm going to do B and C first, because figuring out the equation of the axis and the period of the function, it's going to help us to graph the function. So I think those should be first, and then we can do A last. We can come back to it. Okay? So what is the equation of the axis? Well, the equation of the axis is by default going to just be 0, right? Going to be y equals to, or sorry, it's going to just, it's going to be 0, right? Or y equals 0. But in this case, we've shifted down 3, right? I see a negative 3 at the end of this equation, which means the equation of the axis is y equals to minus 3. So let's go down 1, 2, 3 to negative 3. And this is our equation of the axis. Like that. Awesome. All right, so that is that. Next, it says state the period of the function. Well, what is the period of the function? The period of the function is 2 pi over the b value, right? The k value in this case, sometimes we call it the b value. But in this case, there's just an invisible 1 here. So the period length would just be 2 pi over that invisible 1, which is just 2 pi. So the period length does not actually change here because of this equation. Okay, now let's draw the rest of the equation and how it's going to go. So I see a negative sign here, which means we are going to flip this. I also see a 2, which means our amplitude is going to be 2 instead of 1. So we're going to start here. And then we're going to just follow our regular pattern because the period length does not change. Okay? So let's do this one. Let's say this is pi over 2. Pi 3 pi over 2, and then all the way over here, 2 pi. Okay, so let's put that there, and then here, here, and finally here. Like that. And there we go. There's our graph. One thing I strongly recommend doing with these is double checking each part of it, because it's very easy to completely know what you're doing, but still miss something, and just forget to include it. So I'm going to go back to my equation. I'm going to check that I did not miss anything here. Okay, partly for the sake of this, but also it's good to check. Maybe I made a mistake. So let's see. So did I remember to reflect it in the x-axis? Yes, this does look like a reflected cosine graph where we start at the bottom at the minimum and then go up to the maximum, come back down. Whereas the regular cosine graph, we start at the maximum, we go down to the minimum, we come back. Next question, is the amplitude indeed 2 as it shows in the equation? Yes, it is. Okay, next question. I didn't. I made a mistake here. Did I shift right by pi over 2? No, I didn't. I didn't do that. I did not shift right by pi over 2. So let's do that now, actually. I'm going to make a new graph and say this color is g of x, and the black one is just, part of our way to get there. So negative pi over 2, right, means that we shift right by pi over 2. So I'm going to shift this one to here. I'm going to shift this dot to here. I'm going to shift this dot here. I'm going to shift this dot over here. And then there would be another one like this if we were to continue the pattern. So there we go. That's how the pattern would go. It would go like that. So there we go. Okay. All right, so now we have done that indeed, even though before we hadn't done it, now we have. And then did I go down 3? Was this shifted downwards by 3? Yes, it was. We already accounted for the equation of the new axis. So there we are. We're good to go. So yeah, so I strongly recommend doing that because it's, yeah, like I was saying, it's very easy to, think we've done everything, but not quite have remembered to do every single transformation because it's a lot at once. It's kind of a lot all at once that we're doing when we are doing transformations. Okay, let's move on to the next example, um, oh, which is example 4. Looks like there's 2 more examples left for today. There are. Okay, so example 4 says, given the parent function y equals sine x, sketch this graph and state the equation of the axis and state the period of the function. Okay, so first I'm actually going to do B and C because they're a lot easier and they'll help us to sketch the graph. Because for sketching the graph, we've got to know all the transformations, we've got to do everything. For these ones, we just have to do one step that we would have to do anyway for our graph. So for example 4, for B, it says state the equation of the axis. Well, I see a plus 2 over here, which means the equation of the axis has shifted from y equals 0 to y equals 2. So y equals 2 is the equation of the axis. Now, what about the period length? The period length is going to be 2 pi over the absolute value of the k value, which is negative a half, right? I see my k value right there. It's negative a half. So that's going to be 2 pi divided by a half, which is going to be 4 pi. So therefore, 4 pi is the period length. Okay, awesome. Okay, so now that we figured that out, let's sketch our graph. So I'm first going to draw my new axis, which is going to be up here at y equals to 2, like that. And then let's see what else. Our amplitude is still 1. We're not doing any reflection in the x-axis. We are reflecting in the y-axis though. Okay, that's good to keep in mind. We'll be reflecting in our y-axis, or our new equation of axis. And then, we'll be shifting pi over 4. Okay, so this time actually I'm going to do everything except for the shift. We're going to do the shift last. So I'm going to do kind of the same thing as last time, except this time purposefully. Let's plot all this out. So we need, let's see, this is going to be pi, 2 pi, 3 pi, and then over here 4 pi. There we go. Okay. And then same thing with here. We have negative pi, negative 2 pi, and then negative 3 pi. Oh no, that's not right. Negative 3 pi wouldn't be till here. Awesome. Okay. Very good. Very, very good. So now let's start to plot some of these. So we know that it's sine, and for now we're going to skip the one part of it. We're just going to act as though we're switching the period length and the vertical shift. So in that case, we would start here at 0, 0, or 0, 2, because we're shifting up 2 and we are accounting for that. And then what will we do next here? We're going to go and do our regular sine pattern, except we are going to reflect, right? We're going to reflect in our y-axis. Okay, so normally we would have what? We would have something like this. Up 1, here, down here, and here. This is what we would normally have, correct? We'd normally have something like this. And then this way we'd have ch, and so on. So in this case, reflecting in our x-axis is actually going to be the same as reflecting in our y-axis. So our new one is going to be like this. We're going to go down first, like that, and then up, and then back down to here, and then up, down, and so on. So there we go. There's our new one. And now to get our final answer, which I'll do in purple, I'm going to circle this in purple to show this is my final answer. The other ones were just ones we're doing to, to kind of do the progressions, to do those steps. It's going to look like this. Okay. So it's going to be moved pi over 4 to the left. Okay, so pi over 4 is one of these squares, right? Because every 4 of them is pi, so pi over 4 is one square to the left. So I'm going to move this one here. 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 So there we go. Okay. And there we go. There is our final answer there. Awesome. And now I'm going to double check. I'm going to double check to make sure. So we did do sine. Yes, we did. And then we did do our reflection, and we also did do our horizontal stretch, which yes, we did, because we accounted for the fact that the period length is going to be 4 pi. So we did do that. We did our shift left by pi over 4, and we did do our up 2. And so we did everything. So we're good. All right, let's do example 5. Let's do example 5 as our last example for today, because I know this is getting, how long is this getting? Yeah, this is getting kind of long. Okay, we'll be done soon after example 5, I promise. Okay, so for this one, it says sketch the function, state the equation of the axis, and state the period of the function. So in this one thing I want to point out right away is I'm noticing this is not in the right form. This is not factored. So this is the same as g of x is equal to 3 cosine and then 2 times x minus pi over 6 plus 1. What a lot of people would do is they would see this and they would think, oh, phase shift right, pi over 3. But no, that's not right. It's phase shift right by pi over 6 because it must be in factored form. It must be in the correct format for it to be right. Very good. Okay, so now let's state the equation of the axis. So I see a plus 1 at the end, so that means y equals 1 must be my equation of the axis. And while we're at it, I'm going to just draw a dotted line there to remind ourselves that that's our equation of our axis. And then what is the period length? Well, the period length is 2 pi over the absolute value of k, which in this case, k is this 2 right here. So it's 2 pi over 2, which is pi. So in this case, the period length is pi. So it is compressed down to pi, right? Because normally it is 2 pi, and we're compressing it by a half, right? Okay. I mean, it won't look very compressed because I'm just going to draw, I'm just going to label my grid accordingly so that we can still show it properly. But yes, it is, just know that it is compressed. Okay. So let's plot our points. And let's also, actually, first I'm going to label the graph. So here we have, let's do pi over 4, pi over 2, 3 pi over 4, and pi. So that's going to be a full period length. Okay. Now let's account for the fact that it's cosine, and we're going to start up here 3 above, and then we're going to go down here, and then down again, down 3 again, up 3 again, and there. So we've accounted for everything in this case except for the phase shift, okay? So this is good, except we didn't do the phase shift, and that's okay. We're going to do it in the next step. Phase shift is always the hardest one I find. So I like to do it like this, and then we'll include the phase shift after. Because here we included the new period length, we included the amplitude, and we included the vertical shift. We just now need to include the phase shift, which is to go left by pi over 6. So if each of these is pi over 4, then pi over 6 is going to be a bit less, right? than the full pi over 4. So it's less than that. However, each of these here, this is would be pi over 8, right? And pi over 6 is more than pi over 8. So it's going to, we're going to shift it about like around there. So about a thing and a little bit. So just over a unit there, just over a unit there, just over a unit there, and just over a unit there. So there we go. Oh, and it was supposed to be, sorry, I shifted it left. I was supposed to shift it right. Okay. So actually let's try that again. Because it's supposed to be shifted right, not left. And I was shifting it left. Okay. There we go. All right, well, there it is. We have finished this problem officially. So good work today, everyone. And I will see everybody back for the next day. Oh, and I should circle this and this because these are the same thing. But yeah, good work today, everyone. And I will see everyone for the next class. Bye, everyone.